Quiz 2 key, alkyne, Cl2. Things I saw, people forgot, right, that you need that third arrow. There should be no carbocation here. Third arrow, again, somebody might ask, well, wait a second. Chlorine should add, but remember we check our solvent, you have a polar protic solvent. Those polar protic solvents get involved, they're going to add. And somebody might ask, well, how do I know it adds? This is an internal alkyne, right? Both of these are equally substituted. But if you look at the product, this solvent needs to add to that carbon. So that's why it happens. There's like an SN2, get that trans drawing, and then there's a proton transfer to make that HCl. Biggest things I saw, bond angles here. Got to have good bond angles, right? Third arrow, and then don't forget to use the solvent. So part 2, I just took this down and did the same thing with Br2. People got goofed up on this. This is like an old reaction actually we've done. You get this one now, right? This is where it got a little harder because now you don't have the product. So I wanted to see, right, if you remember the wedges and the dashes, when this is an alkene reaction, how does that work? Br2, same idea. 3 arrows, just like Cl2. Make a 3-membered ring, but now you do have wedges and dashes because you no longer have a pi bond. And now in this case, it didn't really matter if the bromine went here or here. I was fine with either way. Didn't matter. What I wanted to see, though, I wanted to make sure you show the bromines trans, these two on the same side and these two on the same side. So I was really looking for that stereochemistry part, was that product, right? So 5 points were for the arrows, 1 point was for the product, and then another point was for like the actual stereochemistry, the wedges and the dashes, all being correct. Okay, so this one, a little acid-base kind of chemistry, but also thinking about hybridization and resonance and all that stuff. Label them acid and base. Do a good job. Acid base. Bases are electron rich. Draw the mechanism arrow. 2 arrows. That's good. 2 points. Products. Conjugate base. Conjugate acid. Labeled. This is the base because now it has a negative charge. This is the acid because it's the one that got the going the other way. You'd be acidic. And then equilibrium, you could argue it 2 ways. I wrote the products are favored, which is always right. But I wrote because the conjugate base is more stable, right? Because this is more stable because of resonance. You also could have written, you could have drawn resonance structures of the starting material, the acid, and said it's more reactive because of resonance. You could have also done that, right? So either way is a fine answer, but always the equilibrium lies towards the products.